Properties of exponents. Our objective is to simplify expressions involving exponents, as well as use scientific notation. Who uses this? Astronomers use exponents when working with large distances, such as that between Earth and the Eagle Nebula. When you're dealing with a base and an exponent, your base is your bottom number and your exponent is like your power. So A is a factor n times. When the base includes more than one symbol, it is written in parentheses. Really important, guys. When the base includes more than one symbol, it is written in parentheses. So let's look at this chart below. So in exponential form, we have negative 2x to the third. Notice how there are no parentheses around any of this. That means your exponent of 3 only refers to the x. So your base is x. In expanded form, you would have negative 2 times the quantity x times x times x times, x times x times x. And now, for another one, we have negative, and then our parentheses are around the 2x. So the 2x is being done to the third power. So our 2x is our base. So in expanded form, our negative kind of still chills out in front, and then we have 2x times 2x times 2x. And the last one. Our parentheses include the entire value here. So it includes negative 2x. So our base is that whole quantity, negative 2x. So that base is what is being multiplied 3 times, because negative 2x is a factor 3 times. So negative 2x times negative 2x times negative 2x. In the end, it's easy to remember if you just think about it this way. When the base includes more than one symbol, it is written in parentheses. All right, let's practice. So write each expression in expanded form. So for our first example, we have 4y. The 4y is in parentheses, so our base is 4y, and that's going to be a factor 3 times. So in expanded form, we would have 4y times 4y times 4y. Take a moment and pause the video and try B and C on your own. Now that you've had a chance to try B and C on your own, let's try them together. Notice how there are no parentheses. Therefore, your base is only the A, not minus A. So our A is squared, and the minus kind of will just chill out in front for a while. So we have minus and A times A. You can simplify it to negative A times A as well. Alright, let's look at C. We have 2y squared times the quantity x minus 3 to the third. In this first piece, notice the y is the only term being squared. So y is your base. In the second piece here, notice that x minus 3 is in parentheses. So x minus 3, that quantity is going to be a factor 3 times. So let's see what it looks like. 2 times y, and then x minus 3 times x minus 3 times x minus 3. Let's look at zero and negative exponents. The zero exponent property. A non-zero quantity raised to the 0 power is equal to 1. It doesn't matter what number you pick. 100 to the 0 power is 1. 4 billion to the 0 power is 1. Doesn't matter what number you pick. If it's to the 0 power, the answer is going to be 1. The negative exponent property is a little bit trickier. A non-zero base raised to a negative exponent is equal to the reciprocal of the base raised to the opposite positive exponent. So we're going to focus on changing our negative exponent into a positive exponent. So we have 7 to the negative second power equals 1/7 to the positive second power. Originally, if you looked at 7, the base of 7 can be written as 7 over 1. So when you find the reciprocal of 7 over 1, that would be 1 over 7. And then you can simplify by putting your 2 in with your 1 and your 7. So 1 to the second power is 1, and 7 to the second power, you can leave it as an exponent, or you could have put 49. What about if you start with a fraction? Well, in parentheses, we have 3 halves, and that 3 halves is being raised to the negative 4th power. Well, to simplify, we want to get rid of this negative 4, so to make it a positive exponent, we reciprocate the base. So the reciprocal of the base in this case would be 2 over 3. Let's practice. Simplify each expression. We have 2 to the negative third. Well, 2 can be written as 2 over 1. So if we want a positive exponent, we need to reciprocate 2 over 1. The reciprocal of 2 over 1 is 1 over 2. And 1 to the third is still 1. And 2 to the third, you can leave it as such, or 2 to the third is 8. Take a moment and pause the video and try B. Now that you've had a moment to try B, let's try it together. So we have negative, and then in parentheses we have 3/4 to the negative 4th power. Notice the parentheses are only around the 3/4, not the negative. So this being a negative and this being a negative exponent, they have nothing to do with each other. They're not going to cancel each other out. It does not work like that. However, to make this negative 4 into a positive exponent, we're going to reciprocate 3 over 4 to see it as 4 over 3. And the negative chills out in front. If you'd like, we can continue to simplify, leaving us with negative 256 over 81. Let's look at some more properties of exponents. The product of powers property. To multiply powers with the same base, add the exponents. So notice you have the same base of 4, so we're going to simply add the exponents. So 4 to the third plus 2, so 4 to the 5th. And how about the quotient of powers property? To divide powers with the same base, subtract the exponents. So say you had 3 to the 7th power over 3 to the 2nd power, you would simply subtract. So 3 to the 7 minus 2, which is the same as saying 3 to the 5th. Power of a power property. To raise one power to another, multiply the exponents. So 4 to the 3rd to the 2nd is the same as 4 to the 3rd times 2, or 4 to the 6th. Alright, now let's look at power of a product property. Find the power of a product. Apply the exponent to each factor. So say we had 3 times 4, and that quantity was raised to the 2nd power. That's the same thing as saying 3 to the 2nd times 4 to the 2nd. And our last one here is the power of a quotient property. So to find the power of a quotient, apply the exponent to the numerator and denominator. So say you had 3/5, that quantity to the 2nd power. You can simply simplify this by saying you have 3 to the 2nd power divided by 5 to the 2nd power. Let's practice these. Simplify each expression. Assume all variables are non-zero. So in the first one, we have 2x to the third times negative 5x. Well, we have our 2 times our negative 5, and then we have x to the third times x. We can combine 2 times negative 5 to give us negative 10. And then we have exponents here, and they have the same base. And we're multiplying, so since we're multiplying powers with the same base, we're going to add exponents. So we're left with negative 10x to the fourth. Take a moment and try B on your own. Now that you've had a moment to try B, let's try it together. So we have the quantity ab to the fourth divided by b squared. That whole quantity is to the second power. So let's start with raising each piece to the second power. So we have a times b, and that b value is to the 4 minus 7, because 4 and 7, notice how it's a quotient, so you're going to subtract. So now we're left with the quantity a times b to the negative third, and that's being raised to the second. So we're going to use the power of a product property. So we have a squared times b to the negative third to the second. So to simplify this again, now we're going to use power of a power. So we have a squared times b, and then we're going to multiply our negative third and second, leaving us with a to the second times b to the negative sixth. We don't want negative exponents. So to make this a positive exponent, we need to move b to the denominator, leaving us with a squared divided by b to the sixth. Alright, let's take a look at scientific notation and standard notation. So say you had 1.275 times 10 to the 7th. To put this in standard notation, you would have to move the decimal to the right 7 places, leaving you with 12,750,000. If you wanted to go back towards scientific notation, you would have to move the decimal to the left to go back towards scientific notation. So basically, scientific notation and standard notation, you're just moving the decimal back and forth. Just keep in mind which way you're moving it. Let's practice. Simplify each expression. Write the answer in scientific notation. So we have 9.1 times 10 to the negative third divided by 3.1 times 10 to the 8th. So let's start by dividing our 9.1 by 1.3 and our 10 to the negative third and 10 to the 8th. Well, 9.1 divided by 1.3 is 7, and then 10 to the negative third divided by 10 to the 8th is 10 to the negative 11th. So to write this in scientific notation, we would have 7.0 times 10 to the negative 11th. Take a moment and try B on your own. When you return, the answer will be revealed. Now that you've had a chance to try it on your own, let's look at it. We have 3.5 times our 5.2, and then we're going to have our 10 to the 8th times 10 to the 5th. And when we simplify, we're left with 1.82 times 10 to the 14th. And that ends our lesson on properties of exponents.